So today we're going to talk about the distributive property, and more importantly, why the distributive property works. And we're going to use actual numbers. So think of this going way back, pre-algebra, but the concept, the rules are still the same when we bring in algebraic terms. So let's start with this lovely rectangular array. As you see, we have here 3 rows, 1, 2, 3. So I'm putting the number there, and then we have a total of 5 columns. Now to find how many chips we have in total, we multiply 3 rows times 5 columns. It's going to give me 15, and I can prove that by counting. There are 15 chips. Now I can break up this number 5 represents the number of columns into these 2 columns, the yellow columns and the red columns. And I can also write that expression as 2 plus 3. 2 plus 3 is an equivalent expression that equals 5. It represents the 2 yellow columns plus the 3 red column gives me the total of 5 columns. So this expression should be equal to 15 as well. Now let's distribute. The 3 is being multiplied to this entire expression inside the parentheses. It's not being multiplied to just a part of it. It's being multiplied to all of its parts. 3 times 2 plus, and then again, the 3 outside is being distributed to the other part, which is this other 3 here. 3 times 2 is 6, plus 3 times 3 is 9, and then we add those two numbers, it gives me 15, just like this number. If we fail to distribute the number outside the parentheses to all of the parts, let's say we only distribute the 3 to the 2, then we get 3 times 2 plus the 3 without the number outside being distributed to this other part of the expression. And that would give me 6 plus 3, and 6 plus 3 is 9. And if we count, we don't have 9 chips. We have 15, so this is not correct. Let's do another example. Okay. So for example, let's say I have 4 times 20. So 4 times 20, 4 groups of 20 is going to give me 80. And I can put that in the calculator. And I can check if I wanted to using arithmetics. I know that 4 times 20 means I have 4 groups of 20. Multiplication is repetitive addition. So if I'm repeatedly adding the same number, I can rewrite it as a multiplication expression. 4 groups of 20, 20, 40, 60, 80. Yep, I'm right. Now I can write 20. 20 can also be written as, for example, 5 plus 5 plus 10. Or I can make it a little bit more interesting. I could do 3 plus 7 plus 10. That expression, 3 plus 7 plus 10, represents or is equal to the number 20. If I multiply 4 times this expression, remember this whole number needs to be multiplied by 4. This whole number is represented by this expression, 3 plus 7 plus 10. So I have to make sure that that 4 is being distributed to all the parts of this expression. There are 4 groups of 3 plus 4 groups of 7 plus 4 groups of 10 for a total of 20 groups of 4. So 4 times 3 is going to give me, I can write it like this just so I don't forget that 4 is being distributed to the 3, the 7, and to the 10. 4 times 3 is going to give me 12 plus 4 times 7 is going to give me 28 plus 4 times 10 is going to give me 40. And then I can continue adding. 28 plus 12 is going to give me 40. And then 40, that comes down. 40 plus 40 is equal to 80. You don't have to show all of this. I'm just kind of showing you 4 times 3 equals 12, plus 4 times 7 equals 28, plus 4 times 10 equals 40. And add all of those together is going to give me 80, the same thing as this. If I don't distribute the 4 to all the parts that equal this expression, then I'm not going to get a number that is equivalent to 80. I'm going to get incorrect answer. Hope this makes sense.